Hello, boys and girls. It's Mrs. Bartel. I am hoping that you watched the instructional videos that I linked. So I'm just here to kind of go over the little follow-up activity after that. So today's lesson is Unit 7, Lesson 4 for math, and we're comparing unit fractions with fraction bars. And I certainly hope that you have the construction fraction bars out that we made in class. Those will be extremely helpful for this. I want to look at this word right here, compare, and I want to review the symbols that we would use in math when we're comparing two things. So I'm not going to use fractions for this either. I'm just going to use some numbers up here. If I have the number 8 and I have the number 3, I know that 8 is greater than 3. So this symbol right here, boys and girls, means greater than. So that is a symbol that we would use to compare. Did I spell greater? Yes, I did. Okay. Then if I have this, let's see, 5, and over here I have 8. Right here I can tell that 5 is less than 8. So this is the less than symbol. And I am pretty sure we talked about these symbols kind of representing a mouth. Like you always want to eat the greater amount, right? If you have 8 cookies or 3 cookies, you're going to choose the 8 cookies, right? If you had 5 cookies, you don't want to choose that one because it's less than the 8. You always want to choose the one with the most. And you know how I like to compare things with food, especially cookies or chocolate, right? Or candy or pizza, anything yummy. All right, so if you're looking at these fraction bars right here that they give you, they're not cut out or anything like the ones that you have, so they're not easy to manipulate. But you can see that all of these, one whole, 2 halves, now 2 halves, boys and girls, is the whole. 3/3, that's the whole. 4/4, that's the whole. All of these wholes are the same exact size. And we talked about that in class, how that's important, that when you're comparing fractions, when you're comparing unit fractions, the actual size of the whole must be the same, okay? It must be the same. And then what we did was we drew some pictures, and I'm not sure if you have your math journal with you, or maybe we didn't do it on a math journal, but if I have this pizza and I cut this little pizza into 4 pieces, you can shade 1/4 right there, right? Now I'm going to take another pizza and I'm going to cut this pizza into 4 pieces, and I'm going to shade the same thing, 1/4. Boys and girls, it's quite apparent this 4th is not the same size as this 4th. And that's because the size of the whole is not the same. So when we are comparing unit fractions with these fraction bars, it's important to note that the size of the whole is the same so that we can compare them properly. So you can see they have the unit fraction listed in each. Remember, boys and girls, unit means 1. The numerator will always be 1 when we're referring to a unit fraction. So here we have halves, here we have thirds, fourths, fifths, sixths, sevenths, and eighths. And right down here, they're wanting you to describe some patterns that you see, specifically 2 patterns. So I see a lot of patterns in here. So I'm going to just kind of take what I'm noticing. The whole is the whole shebang, right? It's the whole thing, the entire thing. It's not divided into smaller pieces. But if you look here at half, and then a third, and then fourths, fifths, sixths, sevenths, and eighths, I want you to remember what we talked about in class. what your noticings were in class about that. We had some powerful noticings. What we came up with, as long as the numerator continues to be 1, if we're just comparing the unit fraction, the smaller the denominator, the larger the piece, because that means the whole is cut into bigger pieces. So the larger the denominator, the smaller the piece. And you can see here that the unit fraction the size of the unit fraction keeps getting smaller. The more times you divide it, it gets smaller and smaller. And so if you're looking just at the denominator here, on the bottom part of the fraction, the denominator, the bigger the denominator, the smaller the unit fraction. Or you can look at it this way: the smaller the denominator, the bigger the unit fraction. Okay, that's one noticing. Another noticing I have, and I'm hoping you came up with this as well, I'm seeing some equivalent fractions here. I'm seeing that 1/2 is equivalent to 1/4 and 1/4. So see how this lines up here? So 1/4 and 1/4, that's 2/4, and that's equivalent to 1/2. I'm also noticing, if I look at my 1/3, I'm noticing that 1/6 and 1/6, which make 2/6, that's equivalent to 1/3. So that's another noticing that you might have. So right here, your job is to describe 2 of the patterns. I just talked about a couple of the patterns. You can pause the video and jot your notes down, or pause and check your work. Okay, so if we're comparing, as long as the numerator is the same, we talked about this up here, as long as we're comparing with the same numerator, the bigger the denominator, the smaller the unit fraction. And I say unit fraction here because all of these numerators are 1, signifying a unit fraction. So if I have 1/3 and 1/7, I know that if I took the whole and I divided it into 3 equal pieces, those pieces are going to be a lot larger than taking that same exact whole and dividing it into 7 pieces. So 1/3 is going to be greater than 1/7. Remember, this was divided into more pieces. So the pieces keep getting smaller. The more you divide the whole into more and more and more pieces, the smaller that unit is going to get. So over here, 1/3 and 1/2. You can even check your work up here, boys and girls, by relooking. But if I took a whole and I divided it into 3 pieces, that's going to be a lot smaller than taking that same exact whole and dividing it into 2 pieces. Okay? And over here, 1/6 and 1/7. 1/6 is going to be greater than 1/7. Remember, as long as the numerator stays the same, the smaller the denominator, the greater the fraction. Or you could look at it like this: as long as the numerator stays the same, the larger the denominator, the smaller the fraction. Okay? All right, so that was that piece. Now we are into comparing unit fractions with number lines. And they're wanting you to describe a pattern that you see on this number line right here. Okay? So, first of all, if I was doing this in class with you, I would probably go ahead and draw 1, 2, 3, 4, 5. I'd probably draw 5 number lines. I like mine on top of each other. I don't like to have them all crowded like this. but I want you to look at that and try to think about what you're seeing. What I'm seeing already and noticing I have is that they're just plotting unit fractions. All of the numerators are 1, and they're all out of the same whole. So the size of the whole for each of these is the exact same. One of my noticings that I have is that all of the unit fractions are to the left of 1/2. They are all plotted to the left of 1/2. The spaces between the unit fractions get smaller and smaller as you move to the left. So, for example, the space between 0 and 1/2, it's pretty huge. The space between 0 and 1/3, it gets smaller. Between 0 and 1/4, it gets smaller. And then if you just compare between the two unit fractions, the space keeps getting smaller as well. So those are some noticings that I have. All right, comparing using fraction bars. I really highly recommend that you're drawing these, boys and girls, on a fraction bar. Super important to practice to be able to divide the same size whole into parts, into equal parts. Obviously, the numerator is all, these are all unit fractions because the numerator is 1 on every single one of these. So those are pretty easy. You could probably zip right through that because remember, the smaller the denominator, the larger the unit fraction, okay? Or you can look at it like this. The larger the denominator, the smaller the unit fraction. Okay, so you should be able to zip through with those, deciding which is greater than or less than. And if you can't, remember, you need to use your fraction bars, or you can flip back. So if I'm looking at 1/3 and 1/8, you can flip back to the front and you can see your third and you can see your eighth. And then you can tell that 1/3 is a lot larger than 1/8. So over here, 1/3 would be greater than 1/8. Okay? So let's skip down to number 12. I'm not going to go over the rest of those with you. You should be able to do those. Between which two unit fractions would 1/5 fall on the number line? And they're talking about the number line up here, boys and girls. Where would 1/5 fall? Think about that. 2, 3, 4. Where do you think 1/5 would fall? 6, 8. Where do you think? Yes, you're right. It would fall between 1/6 and 1/4. You are absolutely right. Good job. 1/6, and remember our little symbol for and, our little shortcut there, 1/4. It would fall between those. Now, in our class, we know we could say it would fall between 1/4 and 1/6. So either one of these, however you want to write that, that's fine with me. Think about making a fraction bar for tenths. I can't remember if we did this in class. I don't think we made tenths. How many unit fractions would be in the fraction bar? Well, let's look over here. Let's look over here for eighths. How many unit fractions are there to make up 8/8? How many are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. How many unit fractions are there to make up 7/7? There's 7 of those. So think about tenths, boys and girls. How many unit fractions would it take to make 10 tenths? There should be 10 of them. There should be 10 of them. How do you write the unit fraction for 1/10? 1/10. Okay. They have a little predicting problem for you. Can the fraction bars for any unit fractions when even... Let me reread that. Can the fraction bars for any unit fractions with even denominators always be split into 2 equal parts? And explain. Well, I'm thinking about just the number 10. 10 can be split into 2 equal parts. Hold up both of your hands. If you put both of your hands up, you have 5 fingers on each hand, and that's 10. How many hands is that? It's 2. So if you split 10 in half, that's 5. If you split 8 in half, that's 4. If you split 4 in half, that's 2. Think about if you split 20 in half, that'd be 10. If you split 18 in half, that'd be 9. So can the fraction bars for any unit fractions with an even denominator always be split into 2 equal parts? The answer would definitely be yes. All even numbers can be written as a sum of 2 equal numbers. In other words, 2 plus 2 equals 4. 4 plus 4 equals 8. 8 plus 8 equals 16. How about this? 3 plus 3 equals 6. 5 plus 5 equals 10. So the sum of 2 equal numbers, okay, those are going to give you even numbers. So the fraction bar would definitely split into 2 equal parts. All right, boys and girls, that was it for today's lesson. Miss you. Bye.